America's plans for a manned space station were still at the computer stage. High over Earth, another orbiter had been busy for years, a workshop in the sky. It was the Soviet station, Mir. The word means peace. The complex had been assembled module by module since 1986. Crews commuted to Mir by Soyuz ferry. Foreigners participated. There were lucrative commercial contracts. A link-up with the American space shuttle was planned. Mir was so successful that it survived the demise of the Soviet Union. Less fortunate was the Soviet version of space shuttle, Buran. Pictured here on the back of the world's most powerful rocket, Energia, Buran flew by remote control. Lifted into orbit by Energia, Buran had one unmanned flight and a doubtful future. Russian ambitions could now lie with the projected European shuttle, Hermes, here with its mini space station, Columbia Free Flyer. A joint venture with the European Space Agency is a possibility. The Japanese are also interested in a manned mini shuttle. But the Europeans' biggest push will continue with Ariane. This is Ariane 5, planned as the world's most efficient launcher, capitalizing on the unrivaled record in the deployment of heavy satellites. Ariane 5 is intended to keep the Europeans ahead of commercial rivals in America, Russia, and China. Space Shuttle will remain America's orbital workhorse. In the late 90s, it will help construct the great space station, Freedom. Although Freedom is still being planned, it should look something like this. A collection of bolt-on modules, American, Japanese, European, even Russian, and orbiting United Nations, courtesy of NASA. Shuttle will be invaluable, but possibly too small to ferry the heaviest parts aloft. Freedom will be permanently manned, at once a research laboratory and a platform from which to launch missions to the moon. Shuttle, however, will be eventually phased out, at least as presently designed. The trouble with Shuttle is capacity. It's a taxi rather than a truck, and a costly taxi at that, adequate for carrying small payloads into orbit or launching modestly ambitious probes. But for powerful shots to the outer planets, NASA must rely on rockets such as Titan IV. This could be the next shuttle, a hybrid, half aircraft, half spacecraft. It would be a space plane that could travel from New York to Australia in 45 minutes, or from airport to spaceport in less than half an hour. The technology exists. Indeed, the U.S. military possibly has a smaller version. For the time being, though, NASA is constrained by development and production costs. Sooner or later, Super Shuttle will happen, probably early in the next century. And toward the end of the 21st century, such hybrids could be joyriding through the friction of the upper atmosphere.
Satellite
Tourist excursions, heading for leisure wheels in the sky. A weekend break watching the Earth below and the heavens above. It's science fiction, but as technology advances, there is every possibility of space cities in permanent Earth orbit. Slowly rotating wheels, offering visitors a touch of home-like gravity. A more immediate prospect is a manned return to the moon, last visited in 1972. How much easier it will be to land in the first decade of the 21st century. And with the old rivalries buried, NASA hopes for an international effort. A lunar base would be established. With Shuttle as a kickstart, NASA has longer-term plans for manned missions to Mars. Technologically, they are already feasible. The problem is cost. Initially, there'd be a touchdown on the tiny Martian moon of Phobos. There, astronauts would set up a sort of base camp. Meanwhile, using the thin Martian atmosphere as a brake, a lander would descend to the red planet itself. It would be an enormous enterprise. The round trip from Earth to Mars and back would take 2 years and vast resources. The objective would be a permanent Martian presence. The priority, to erect airtight shelters because Mars is cold and arid and its atmosphere is unbreathable. Complete with oxygen backpacks, explorers would wear pressurized suits and drive Martian rovers. They would search for water, possibly trapped as ice beneath the surface. Water would be a boon. Oxygen could be extracted for breathing supplies, and hydrogen to fuel the rovers. Every scientific device would be employed to establish self-supporting colonies. After all, the nearest supplies would be a year away on Earth. NASA may someday send manned expeditions elsewhere within the inner planet region. But the outer solar system will remain the preserve of robots for now. When the robot Galileo slots into orbit around Jupiter in December 1995, it will have been heading from Earth for 6 years, a journey too far in conditions too harsh for anything but a mechanical explorer. A little later, another mission will be best left to a robot. A one-way ticket to investigate a comet. And shortly after the turn of the century, the orbiter Cassini will rendezvous with Saturn, another odyssey, unlikely as a manned flight. Beyond the planets, where even robots can't yet reach, instruments such as a space telescope must probe and explore. An eye on the cosmos in place of flights to the stars.